Okay, just have a little look at something for you to help you with your experiment you're developing for me. This is the criteria sheet. I hope this is still recording because I can't see myself now. I don't know what it is actually. Hang on. What's going on? Are we recording? We are recording. Okay. Sorry. I got a bit concerned. I couldn't see things. So, you've got an experiment to carry out for me. Antoine Laurent Lavoisier tells us that matter cannot be created nor destroyed, simply transferred or transformed. And I want you to carry out this experiment on Thursday in class. So I do need your risk assessments sort of by late Tuesday, so I can go through them and then send them on to Mrs. Viadrowski to make sure that the gear's there ready for you when you need it. And you can see there's 9 criteria here. Hopefully we're all going to be working at standard or above. So we're aiming for at standard or above, I hope. So first of all, you need to do some reference collection and reading. What is the background to this hypothesis? What are we doing? So clearly we're testing a law. Where does that law come from? Who is this guy Lavoisier? Why is this law important? Would be useful things to find out to put into your background theory. You're going to develop a hypothesis from that, which should then link back to this theory stuff. So have identified multiple links between theory and hypothesis. So Lavoisier's law of constant mass tells us that we cannot create or lose matter. It simply changes or is transferred. And yes, this experiment will seek to find evidence for that or something of that nature. You need an aim. So the aim of the experiment is to test Lavoisier's law, or you can develop a bit of that. These all got linked together. So as you can see up here, if you can use language from the background theory, linking the hypothesis and the aim together, you score nice and high. So then you're going to devise a method. So what is this method? How will I do this? And we talked a bit in class last week about the need to be able to collect all the materials that come off your experiment. You can put things together, but when they react, you can lose gases and matter quite quickly that you can no longer account for. So how do I go about weighing everything to start with, weighing everything at the end, and making sure that I actually don't lose anything in between? What will that look like? So what are my variables? What controls do I need to put in place? What are my variables that I'm dealing with? But obviously, loss of gas is one of those independent variables, which could be a bit of an issue. Have you drawn and labelled your experimental setup correctly? So all the things are correctly named. And of course, this is the one that people always forget, risk. This is the thing I need you to have for me Tuesday. What are the potential risks to you as a person carrying out the experiment, to people around you, your colleagues in your classroom, and the classroom itself? How do I ensure that all 3 are left unharmed by your experiment? You can explode things, but you can explode them safely, basically. So there's a need to ensure that you can show that you can do the experiment without causing harm. If you can't do the experiment. And that's a sticking point before you get started. Having done all that, we'll then run the experiment. So you're going to collect data. So have you included units and precision in your measurement? Are these available in tables and diagrams? You might want some photographs of the setup, maybe. Depends what you're doing. Then, what do your results tell you about your hypothesis? You had an aim. Did you actually achieve that aim or not? What information can you give us here? Is there some strange outliers that don't quite make sense and could suggest a design flaw? Can you improve this for next time? But always thinking back to the theory. What am I trying to prove? So if you can do the background properly, then this becomes much easier. And of course, you're going to finish off with, well, I effectively like calling a conclusion. I'd like to call it a discussion. What does your data tell you about the theory? Have you proven or disproven the hypothesis? Have you been able to show a sophisticated understanding of what you're searching for? So hopefully you're all aiming for these higher areas. So how do you design an experiment to test the law of constant mass? You have to mix things together. So you have to take some reactants and create new products. So you're going to transfer and transform the matter you're working with. Where does it go? Okay. So again, late Tuesday, I want to get a batch of risk assessments. You can work in 2s and 3s. That's okay. You're going to have variations on the same theme, I know. But how can you do it? All over to you. So enjoy planning that, and we'll enjoy some fun working with it on Thursday. I'll see you Thursday.